Pritam, Ravi, can you hear my voice?
Yes, sir.
Shubham, can you hear my voice?
Yes, sir.
Shubham, can you hear my voice? Pritam,
Yes, sir.
क्या आवाज भरायती आहे?
हाँ बराबर सर.
ओके. रवी, रवी, Ravi, it is audible. Shubham, Ravi had Shubham,
Yes,
it
yes,
is,
sir.
can you hear my voice?
Yes,
Can you hear it?
yes, sir.
Okay. Now mute your mic. Mute your mic. We'll start the syllabus. Okay.
Okay, sir.
Yes.
Just mute your mics. Okay. Just mute your mics. If you are any doubts, you can on it. Otherwise, mute your mic. So see, we are going to start a new model that is. Hello. Can you hear me? It is audible.
हाँ सर.
Okay. Now,
हाँ सर.
now please mute your audios and mics. Okay.
हाँ ओके.
Okay. Now just see on your screen the model number 5. Okay, this is the syllabus. In this model number 5, in this model number 5, what you are going to study and what are the concepts in this model number 5. So the model number 5 is related to the metrology aspects in the weldings, okay, and the shoulderings and bracings. So what do you mean by the metrological aspects? Means what the after doing the welding, there is some microstructure changes occurs in the metal which you are going to be weld. Okay, regarding to that structure, microstructure or the structure of the weld workpiece that you are going to study in this module, the formation of the different zone during the heat when the heat is generated by the welding machine, welding during the welding processes by the electro rods or the electrical transformer which is used for the welding processes, the heat is generation. Due to that heat generation, the different zones are been created on the workpiece which you are going to be weld or which had been weld. Okay, that you are going to study in these concepts. Heat affected zone, there are due to the generation of the heat, some zones means what the results in the workpiece which are been affected, and there are macro changes in the microstructure that you are going to study, and some of the parameters affecting the heat affected zone, there are some of the parameters which has to be controlled so that the heat affected zone can be reduced, or the heat affected area in the workpiece which you are going to be, that can be reduced or controlled, that you are going to study. The effects of carbon contents on the structure and the properties of steel. So see, the carbon contents are there in the steel. Okay, the steel is the most probably using metal for the welding purpose. Okay, in that there are so many alloys are there. In from that alloys, one of the alloys is carbon also. So due to the high carbon and the low carbon, what will be the changes occurs in the metal, and what will be the property will be changes properties, mechanical properties can be changed after the welding with the help of the carbon, and what the carbon content affects for the welding, and how does the welding can be carried out by the high carbon and low carbon steel, that we are going to study in this concept. And next is the shrinkage in the weld and residual stresses. So this is the shrinkage after doing the welding. In the previous models of the foundries we have studied, what do you mean by the shrinkage? The shrinkage is nothing but the construct after the molding purpose, that is called as a shrinkage. Then next the residual hello, please mute the mic. Eh, whose mic is on, please mute the mic. Okay, the residual stresses. Residual stresses means what? The stresses which are been trapped inside. Trapped inside means what? Closed inside during the welding process. After completing of the welding process, that come out. That stresses are called residual stresses. And next concept is the concept of electrorods. So what do you mean by the electrodes? How the electrodes are there? Filler rods and flux. Okay, that's something details you are going to study in this concept. And welding defects, the how to detect the welding defects and the causes of the welding defects, and the remedies on the different types of welding defects. Once you do the weldings, there are so many defects may occur. Okay, regarding to that defects, the remedies and the causes of that we are going to study in this concepts. Okay, now next is the solid brazing, soldering, brazing and gas welding. Okay, so this is also one of the concept in this module, the soldering, brazing and gas welding. So there are different types of soldering methods are there, brazing and the gas weldings are there, and the working principles and the operations we are going to study in this module. The principles of an oxygen ethylene welding gas, oxygen hydrogen welding gas, air ethylene welding gas, and gas powder cutting or gas cutting powder. Okay, this both are the different gas cutting and the powder cutting. So these are the some of the welding processes are there, or the soldering and the brazing processes are there, that we are going to study. Okay, then finally the last one is the inspection methods of using the inspections of casting and the welding. So see, this are there are some of the inspection methods are been mentioned in this syllabus for the module number 5, which are usually, or the normally it can be used for the casting inspection. Okay, when you remove the casting by the casting method or the foundry method of, okay, so the final product which is coming out, that can be, that should be inspected for the some of the different types of parameters are there for the inspections, and different types of defects can be identified by this inspection method. So which are that you are going to study? This is one of the usual inspections. Magnetic particles inspection is there, fluorescent particles inspection is there, and ultrasonic radiography inspection is there, eddy current inspection is there, holography methods of inspection. So these are the different types of methods of inspections are being used for identifying the defects and the quality of the weld and the casting that we are going to study in this model number 5. So basically this model number 5 is splitted in three parts. One is the metrological changes occurs in the workpiece during the welding and after the welding and before the welding. Okay, and the second part is the soldering, basing and gas welding related, and the third part is an inspection method. Like this way there are three different parts are there in the model number 5. Each and every concept I have shown you which are the concept we are going to discuss in the classes. Okay, so we are not going to lift any single of the concept, we will try to cover each and every concept of the model number 5. Okay, now let us start with the your syllabus, that is MCW metal casting and welding process by the model number 5. Okay, Now we'll start with the model number 5. Okay, the formation of the different zones in the welding. Okay, these are the formations of the different zone in the welding. You can see in the diagram. If you want, you can zoom it. So these are the this is what the diagram. Now you can read over here. During the welding, when the heat source is interact with the workpiece, the flow of the temperature in the material varies from region to region, resulting in the three designated regions or zone. So see, dear students, before going to this different zones, I will like to share one example with you all. Just have you all experienced, just take one paper and have a matchbox. Just burn the matchstick by the help of the matchbox and keep that matchstick at the middle of that paper. Okay, what will happen? The paper at the middle starts to burn over there. Is it? When it starts to burn, just off the fire, close the fire. Then afterwards you can see that at the middle there will be the hole. That much portion of the paper is been burned and converted into an ash. Then after, well, there is a hole. At the side of the hole there is a black color mark is been there. Okay, that is nothing but the heat affected area where the paper is burned at the middle, that is completely ashed out. Okay, and the side where there is a hole, okay, which has been created by that fire, okay, it has been affected, the heat has been affected over here. You can appear that in a black color. Okay, that is a carbon deposited black color. Then apart from that black color, if you go further, there will be a plain white paper will be there. Whatever the paper you are using, that remains same. There is no any changes over there. So like this way the heat is been affected. So what do you mean by the different zones over here? So see, this is a simple thing, that the heat flows from area to area. The temperature flows from area to area. Just imagine, if you take on a steel bar, if you introduce it to a fire flame, or if you heat it on a fire flame, so what will happen? If you hold it for a longer time, the heat will transfer or travels up to your hand. So finally when it's the total body of the steel bar is been heated, so your hand is also starts to burn over there, you leave your hand. Is it or not? So like this way the temperature and the heat is been flowing through the metals. Okay, when the temperature and the heat is flowing through the metals, okay, obviously the heat is also travels with that one. If the heat is traveling, the temperature of the heat is also flowing for the different degrees. Okay, as the temperature varies, okay, the area which undercomes to while during the traveling of this heat is being get affected over here. Now you can see by this diagram how the zones are being created. Okay, in welding there are three zones are there. One is an fusion zone, second zone is an heat affected zone, and third one is an, hello, anybody having the doubt, and third one is an heat, no, see, fusion zone, heat affected zone, and base zone. Now you can see in this diagram, I will slightly zoom it. Now you can see in this diagram. So this is the welding is done over here. Okay, this is a weld, metal is there, and this is a workpiece is there, which is joined. These two joints is been done by the welding processes. Okay, now you can see over here on this workpiece the weld metal is there. Weld metal means what? After the welding, whatever the metal is deposited by the fusion, okay, that is called as an weld metal. So this is an heat affected zone. So not, sorry, this is called as an fusion zone. This is the first zone that is called as a fusion zone. Why it is called as a fusion zone? Because fusion phenomena is occurring over here. What do you mean by the fusion? The two metals which are going to be joined, that are being converted into a liquid form due to the generation of the heat of an electrodes, okay, due to the closed circuit or by the arc. Due to the arc generation, the heat is generated. Due to the generation of the heat, the workpiece is been melted, and the electrode rod or the filler metal is mixed with the molten metal, okay, and goes under the solidifications and converted into a solid. That solid part is called as an weld part, okay. So this is a fusion zone where is an extreme temperature is there. Over here the extreme temperature is there. For example, if here is an 100 degree Celsius, okay, 100 150 degree Celsius, for example I am giving, okay, in the fusion zone. Then because of this high temperature, okay, the surrounded area of the fusion is been affected, okay. Because of the high temperature, surrounded area has been affected. If you have seen anything, if you are burning anything, okay, the whatever the particular object is burned, the heat is released, sorry, the heat is released by that particular object, and it also affects the surrounding area. Is it or not? Okay, like this way you can see in the uh, this one area is been given, that is called as an heat affected area. If it is an 100 degree Celsius, sorry, in the fusion temperature is there, then in the heat affected area it will be less, it will be 60-40, okay. Then then the next zone is the base zone. In the base zone there is no heat is been transferred over there or temperature is been transferred over there. The base zone is the normal zone of the workpiece, where whatever the microstructure the initial the workpiece as having, same microstructure is remain after the welding also, after the heat transfer also. So that is, this zone is called as an base zone, okay. Now we'll read some few lines so that you can understand. Zone 1, the fusion zone. The fusion zone is an weld metal itself. More specifically, it is a region where the molten metal of the filler rod combines with the molten metal of the workpiece to form weld. This fusion zone can be considered similar to the casting process, where the workpiece metal reaches the molten stage. Molten stage means what? Melting stage. And then allowed to cool. Then afterwards when it melts, then it is allowed to cool. Hence the metal in the fusion zone has an basically a cast structure with the microstructure. Hence the metal in the fusion zone has basically cast structure with the microstructure, reflecting on the cooling rate with the weld. So see, the whatever the microstructure is there, it changes according to the cooling rate, okay. How does the metal cool faster? The microstructure also will change. The property of the fusion zone depends primarily on the filler metal. So whatever the properties will be changed, okay, the initial property is different, after welding the property of that metal will be different, but it depends on the filler material which you are going to be used. On that basis the property of the metal will be depend after the welding, okay. Now you can see the zone 2, heat affected zone. The fusion zone is surrounded by the fusion zone is surrounded by a heat affected zone. The portion that was not melted but subject to evaluate the temperature for a brief period of time. As a result, this portion experienced the change in the microstructure and the mechanical property. Now see over here carefully, the fusion zone is surrounded by an heat affected zone. The portion that was not melted, okay, because the temperature is less compared to the fusion for the heat affected zone, but the subject to violate temperature for a brief period. For a short period it also comes under the temperature of the fusion zone, okay, the heat is affected over there. As a result, the portion experience the change. Because of that short period, the temperature is slightly increased compared to the base metal. Okay, from this area to this area, dot dot area, the temperature is different. From this dot dot area, you can see this is an heat affected area, to the fusion area the temperature is different. So see, if the wood is burning, okay, if the wood is, if you take any fire, uh, chimney or a stove, just you have to take a warm from that fire. Okay, standing from that fire 2 feet, okay, you cannot experience any heat if you are not experiencing any heat. So just for imagine it, that is the base metal zone. If you go further towards the fire, okay, nearly up to 1 or 2 feet, if you are experiencing the heat by the fire, okay, that is called as an heat affected zone. If you are sitting on that fire, if you are going and dip on that fire, if your body is having the fire, that is an fusion zone. Understood? So in the heat affected zone, you are experiencing the fire warmness, okay, the heat of that fire. So because of that heat of an fire, some your body skin may be changes, or if your body skin may be blackish, or it can be change, some dark will be appear. Okay, so that changes occurs due to the heat. Okay, same conditions in the heat affected zone. The temperature in the fusion zone is not much, same temperature is not is there, that same temperature is not there in the heat affected zone. But what is happening over there, some of the heat is been released over there. Due to that, some of the microstructure is been changes. With the help of the microstructure, if the microstructure is been changed, obviously the mechanical property of that particular area will also change, okay, of that workpiece. The extent and the magnitude which changes occur depends preliminarily on the base types of base metal. Okay, the constant the concentrate of an heat output, the metal in this area often weaker than both the base metal and the weld metal, and is so more residual stresses are formed. So see, the heat affected area, the fusion zone, and the heat affected zone and the base zone. The base zone is stronger initially from starting also, from starting itself. Before welding and after welding there is no change in the mechanical property, it is stronger. The fusion zone, what is happening in the fusion zone, due to the melting of the two metals, the new microstructure new microstructures and the new grains are being generated over there. With the help of the new grains and the microstructure, the microstructure is been such is in very in a strong position. It adopts its own mechanical properties and its own structure, and it is going to its having a strong structure. But the heat affected area, over here there is no development of the microstructure is been occurring, only the change in the microstructure is been done. New, there is no new microstructure changes occur, only the initial microstructure, whatever the microstructure is there, in that microstructure slightly changes been occurred over there. Because of the slight change in the microstructure, it loses its property. The property what is having initially, that properties are been lost, and that particular area is undergoing to an weaker section. Okay, now you have understood regarding the zone 3 also, the base metal. Now we'll go for the structure of the weld. Now we can see over here in this diagram, see see in this diagram. So this is the base metal. Base metal means what? Before going for the base metal, you can see this is the welding is been done, or the welding material is been deposited over here, or this is the fusion section. In this fusion section, the workpiece is been melt and the filler material is mixed in that metal. Okay, and the fusion is occurred and the welding is been done. Now in this diagram, just clearly observe the grain structure shape of the grain structure. So this is the base material, base zone of the workpiece. Now see how the size of the grain, and this is a heat affected zone. You can see here what is the size of the grain. See how the size of the grain is there, and in the fusion zone you can see what is the size of the grain. Okay, so see over here the grain size are different. Over here the grain size are in a small tiny one, and over here you can see the grain size is a larger one. Okay, in a longer one. So why does it happens? Okay, the material is the same. This is the same material, ms material you are going to weld, or you can take the stainless steel material you are going to weld. If you are taking the same material to be weld, after welding the same microstructure should be depend. Okay, why the microstructure is changing, why the diagram is showing the different size of grain, what is the reason behind that? So the reason behind that is that the temperature variation, okay, the change in the temperature of the different area of that metal changes the microstructure. Just see, this is a fusion. Over here the temperature is, just you can imagine over here, if it is at 500 degrees Celsius, just imagine. Then from the 500 degrees Celsius heat affected area it comes to 300 degrees Celsius. Slowly it comes to 0. Okay, that when the temperature flows from the higher side, from this side, it slowly starts to reduce when it's come out of that workpiece. As the temperature reduces and the flow of the temperature reduces in the descending order, the microstructure changes also occurs in the same manner. So in this fusion, why the columnar grains are happened? So columnar grains are happened means what? How it is happened? So see, the complete metal structure is been dissolved means what? It is been formed into a liquid form. The metal is not in the solid form over here, it is completely in the liquid form. Okay, the two edges of that metal and also the filler rod is in a liquid form. When both the three metals are in a liquid form, so the microstructure is zero over there. They are not having the microstructure, it is in zero. Then afterwards what is happening, as soon as the temperature starts to reduce over there, if the temperature is been reducing over there, afterwards the reducing the temperature, what will happen, the liquid hot liquid metal or the molten metal starts to cool. When the metal starts to cool, it starts to solidify. Solidification starts from the liquid to solid stage, it starts to convert over there as the temperature decrease. When it starts to convert from liquid to solid, at that moment what happens, the nuclei is generated. What is the nuclei? It is the initial stage of an atom. Okay, when the nuclei is generated, after the nuclei the atoms are generated, after the atoms the molecules are generated. Like this way the new growth of the microstructure is being start. What I am telling, the new growth of the microstructure is being start, because the different types of metals are been mixing with each other. Each and every uh, metals release their own microstructure in the fusion. Okay, then a newly microstructure is being generated. So now you can see over here the columnar grain, okay, is different from the base grain. Okay, over here the microstructure is different from the base. So the initially the workpiece was having the microstructure this way, then due to the fusion and the mixing of the different metal, okay, and the generation of the new microstructure, these types of grains are being generated over here. Okay, now heat affected area, in the heat affected area, so see, this in the heat affected area, it neither melt or neither remains in its original position. It, okay, it never melts completely, it is not going to melt. It is not in a semi solid, it is not in a normal condition. Okay, only it is been affected slightly due to the heat, it is going for the or ready for the melting position. Okay, but it not melting. but it is not melting over here. Okay, but it is not melting over here because of this because of this what you can say, because of this heat, only the slight microstructure is been changes. So whatever the microstructure is there, that has been changed into a small changes occurs. Now you can see over here the small grains are there. The initial microstructure is slightly changed with the help of the heat. Do you can you I hope so you have understood this one. Okay, the structure of the welding. Okay, now let us see the heat affected. Now let us see the heat affected zones. Okay, anybody having the doubts?
No, sir.
Okay,
No, sir.
so the heat affected zones, the welding makes a use of so see, to take a control of this heat affected zones. Okay, there are some of the there are some of the parameters are there. By the help of these parameters you can control. There are some of the parameters are there. With the help of these parameters you can control the heat affected area. Okay, so what are that parameters that we are going to study? So the heat affected zone is an often the weakest part in the weld metal because it neither possesses the property of the base metal nor that of an solidified weld metal. Okay, now see, listen carefully. The heat affected zone is often the weakest part of the metal because so see, the weld portion is there. Okay, where the welding is there, it is the stronger one. Okay, from that weld portion the surrounding part is an weakest part. Okay, why it is called as an weakest part? That is the heat affected zone, because it neither possesses the property of base metal. The base metal, whatever the property is there of that base metal, that is not having the property of that base metal, because the microstructure is being changed compared to the base metal. The heat affected area, the microstructure is changed. Once the microstructure is changed, obviously the mechanical property will also be changed over there. Okay, but the base metal is not affected by the heat, so no property changes will be there. Due to the fusion, okay, the heat generation, the new molecules and the new microstructure is generated over there, so it is adopting the new property over there. Okay, it is having a new property over there, so it will be the stronger one. And the base metal is also having the initial property before welding its own property, it is also stronger one. But only the area which is been affected by the heat, that area becomes an weaker and lose its mechanical property. Okay, possess the property of the base metal, possess the property of the base metal nor that of the solidified weld metal. Consequently, the heat affected zone from the original for the most of the failure of the weld joint. So see, in the welding the heat affected zone always stand has a failure. Okay, if you join the two parts, okay, two parts, if you apply the load, so where you have joined, where you have put the weld, the load, the bar will not cut over there, it will cut from the welding side, apart from that welding side where the heat is been affected. Okay, where the property is been weaker, mechanical property is been made weak, the microstructure is been changed over there. Okay, because of that heat is been affected, that part become a weak and that is going to break over there when you apply the load. Okay, after apply the load on the welding part. Okay, so for that reason you have to reduce the heat affected area. The generation of the heat what is being generated by from that fusion, okay, that you have to reduce that area, okay, by that heat, the heat which is generated during the welding from the fusion zone, due to that heat, the you have to try that maximum area should get affected, okay, that you have to do. So how you are going to do that, the you can avoid the maximum area, sorry, minimum, hello, minimum area that can come under the heat affected zone. So there are some of the parameters that has to be controlled during the welding processes. So which are the parameters? First one is the thermal diffusivity. First one is a thermal diffusivity, second one is an heat input, and third one is an welding speed. What do you mean by the thermal diffusivity? Thermal diffusivity is nothing but the spreading of an heat. You should not spread the heat. The heat should not spread from area to area. The thermal diffusivity of the base material plays an important role in diffusivity is an high. The material cooling rate will be high, hence the heat affected zone will be relatively small. So see, if the heat is not spread for a larger area, so automatically what will happen, the temperature will also be reduced. If the temperature is reduced, the cooling rate will also reduce. What do you mean by the cooling rate? The solidification timing will improve, or the solidification of the fusion will increase in a faster rate. So this is one of the parameters which you have to keep in a consideration for reducing the heat affected area, okay. Then next one, heat input. Heat input means what? The process like oxygen fuel welding, electroslack welding, etc. use an high heat input, thereby increasing the size of an heat affected zone. So see, have you seen the gas welding? You have seen the gas welding and the electrical welding, where the rod is being used and the gas welding is being used. So see, in the gas welding you have seen there is a torch is there. From that torch the flame is coming out. By that flame they are burning. If the 10 or 20 mm or 30 mm spot is to be welded, but they are been affected the surrounding area by the torch, okay, fire flame, okay, in the gas welding. But in the electrode welding only the rod is been used and the particular area is been welded, not all the area. So compared to the arc welding, the heat affected zone is more in the gas welding, okay. And for this reason, the heat input, so whatever the heat you are going to be released, okay, input means what? By the mean, either it may be the gas welding, electroslack welding, or the arc welding, you should try to reduce the heat affected and the heat input. If the heat is high, the size of the heat affected zone will be more. Whereas process like an laser welding or electro beam welding, where, okay, in this process only the particular area, the limited amount of the heat is been resulted and bit, okay, is been resulted on the workpiece, so that the limited area or the minimum area is been affected by the heat. Like this way, this is also one of the parameters by which you can control your heat affected area. Now third one is an welding speed, okay. Welding speed, so see, when you do the welding, okay, the welding speed should high, not it should be fast as possible. Slow welding, what will happen if you are putting on one welding rod at a particular point? What is happening over there? When you putting a welding rod or holding a welding rod in a particular single point, the heat is continuously releasing at particular point only, okay. If the speed is slow, so the maximum heat is been reduced. If you increase your speed in a faster way, so the minimum speed will be released, and the minimum time maximum metal can be melt over there. After melting, the temperature will be reduced in a short time, If the temperature is reducing in the short time, the solidification will occur in a shorter time.